Good morning. I am Eric John Habel, and I am tasked to uh, create a PLC system for these problems mentioned in experiment 4, which is relay logic and latching. So, what we have here is our problems. So, for the first set of problems, we have basic logic operations. For 3.1, make a ladder diagram having 3 switches and 1 buzzer. The buzzer can only be activated by pressing any 2 switches. Pressing one switch or all 3 switches will not activate the buzzer. Show the truth table and logic equation and simplify. So, previously I created a ladder diagram that looks like this, or it is this ladder diagram, and we have our equation here. B1 is equal to these, so this is our equation. So what we're gonna do next for our PLC programming is that we will create a relay solution for that. So since the equation is this, we have about three connected to our three parallel connections connected to our buzzer. So we have that, and for since we have 3 switches, we have 3 inputs, and we have only one output, which is the buzzer. So we have our logic operations here. So if they are connected in series, they have the AND logic operation, and if they are parallel to each other, they are in the OR logic operation. So let's look at our PLC program. So here we have our 3 inputs, and here is our one output, which is the buzzer. So let's just look at our created PLC ladder diagram here. So PLC program, I mean. So here we have our 3 inputs, and here we have our one input, which is the buzzer B1. So we programmed this this PLC with this. So in our first input, which is the switch 1, yes, we have that. So it is connected like this. So let us look back at our operation relay solution. So here we have S1 not, and S2 and S3. So let's look at that. So here we have our switch 1, which is connected to IO. If we look at the here, yes, switch 1 is connected to IO. We can see that it is connected to this. This is a NOT. When you see the status bar in the bottom, it is NOT. Wait. Let me. So here, when you look here at the bottom left, we have the NOT operation. So switch 1 is connected to NOT, and switch 2, which is on I1, you can see that on I1, it is connected to the end, and I2, which is switch 3, connection of switch 3, is connected to the end. So here we have our first term for our sum of products, and our next term for the sum of products is here, S1 S2 S3 not. So we have S1. Where is it? Yes, here. S2 and S3 NOT. So this is our NOT operation connected by all of three connected by AND. And the third term for our sum of products is S1, S2 NOT, S3. So we have switch 1, switch 2 NOT, and switch 3. So these ends are all connected to our OR operation or logic operation, and the result is connected to Q0, which is our output buzzer. So let's simulate our PLC here. So our design is supposed to be uh, is supposed to show buzzers that when you press any two switches, uh, the buzzer will be activated, but it will not activate the buzzer if only one switch is pressed or all three switches are pressed simultaneously. So we have one switch, so it does not activate the buzzer. One switch on S2, it does not activate. One switch on S3, it does not activate. If we press two switches simultaneously, it activates the buzzer. If we press another two, it activates the buzzer. And if we press S1 and S3, it activates the buzzer. But if we press all three at the same time, the buzzer will not activate. So that is how our first first logic operation PLC program is done. For the second, we have make a ladder diagram which contains two lamps and two switches. As momentary switch S1, the momentary switch, will act as the start switch, while S2 toggle switch will be the selector switch. If S2 is at off position and S1 is pressed, L1 will light up. On the other hand, if S2 is at on position and S1 is pressed, L2 will light up. So we have two inputs and two outputs. So let's look at our ladder diagram here. So it is said that if we press S1 is at on position, lamp 1 will light up if S2 is not pressed. But if S2 is pressed simultaneously with S1, L2 will light up. So the lamps will not light up if S1 is not pressed at all. So here we have our relay solution. S1 should be on for any lamp to turn on. So here we have our equation. L1 is equal to S1 S2 naught, and L2 is equal to S1 S2. So our created PLC program for that would be this here: two inputs and two outputs. So let's look at our program. So here we have our two inputs and two outputs. Let's look at the program. So S1 is connected to I0 and S2 is connected to I1, while lamp 1 is connected to Q0 and L2 is connected to Q1. So our operation for L1 at Q0 is, when you look at this relay solution, we have L1 is equal to S1 S2 naught. So let's see, S1 is connected and S2 naught is connected. So it doesn't matter if there are two inputs for the end on the end for S2 naught. It's still the same as if you put S1 and S2 naught there without a third input. So yes, it is connected there. So this here is our S1, S2 not connected to L1. For our second equation, L2 is equal to S1, S2. We have here S1 and S2. There is no not operation since both are not. So they are connected by and it is connected to Q1, which is the output for L2. So let's simulate the PLC program here. So we have S1. So if S1 is off, L1 and L2 should be off too. So let's try. S2, we activate S2, L1 and L2 does not light up. But if we activate S1, L1 lights up since S2 is not pressed. But if S2 is pressed, L2 will light up instead of L1. So that's what we have there. So that's for our for our design number 2 for basic logic operations. So for our design for latching operations, our problem is lamp A turns on when push button 1 is pressed and even when released. The same thing happens to push button 2 in controlling lamp B. Each lamp will only be reset by push button 3. The first push button to be activated will disable the next push button until push button 3 resets the system. Make the ladder diagram. So we already have our ladder diagram from our previous experiment for this. So we have our latching operation for lamp A and our latching operation for lamp B, but we have a third button, push button 3, for resetting the lamps. But there's a condition that if we already press one of the push button 1 or push button 2 buttons, if we push, say, push button 1 and if we push button 2 next, push button 1 is activated, so lamp A is activated. But if we press push button 2, lamp B should not be activated, but lamp A would still persist. So that's our condition. And looking at our relay solution, we have this push button 1 is connected in series with lamp B not and PB3 not. So, and it is in parallel with lamp A. So what this means is that if we push button 1, it will activate the lamp A relay and lamp A sustains itself. So if we release push button 1, it will still, the lamp A would still be on. But if we push lamp B, if lamp B is activated, rather, lamp A cannot be activated since the connection will be broken. This is the same as push button 3, but push button 3 takes priority over the activation of lamp B. So next is our push button 2, which works on the same principle, but instead of lamp B, lamp A. If lamp A is activated, lamp B cannot be activated, and lamp B sustains itself if it is activated once. So let's look at our PLC program for our problem for latching. So here we have 3 inputs: push button 1, push button 2, and push button 3, and our outputs, which are 2, lamp A and lamp B. So This is push button 1, push button 2, push button 3, connected to I0, I1, and I2 respectively, and Q0 and Q1 for lamp A and lamp B respectively. So we can see that our our operation for uh, this is that let's look back at here, is that push button 1 input is connected in series with lamp B and push button 3 not lamp B not and push button 3 not. So the but the output for lamp A will be connected again in parallel with push button 1. So the same happens, but for lamp B, lamp A is not is connected in series with push button 2 and push button 3 not, and the output of lamp B is connected in parallel with push button 2. So as we have said earlier, if our connection is in series, it is the AND operation, while if it is in parallel, it is connected in the OR operation. So let's look at that again. So we have here our switch, push button 1 rather, is connected to this OR operation. And when we look at the where it is connected to, it is connected to the output of the AND here. So when let's just ignore that for a moment, and here our push button 1 is connected to the AND operation, and it is connected with here push button 3 connected to I2. So I push button 3 not is connected in the AND operation with this here is the output for our lamp B. So lamp B not and push button 1. So our design here is fulfilled. So push button 1 and lamp B not and push button 3 not. So that's what we have here. And our OR operation with PB1 and lamp A is fulfilled here. So the lamp A output is connected to the OR with push button 1. So that's what we have for our lamp A output. For our lamp B output, we have essentially the same configuration. So here we have our push button 2 connected to the OR operation with the output for lamp B. So this is connected to the AND operation, since it is in series, with push button 3 not, and the output for lamp A connected to the NOT operation. So that is our relay solution for lamp B. So PB2 and lamp A NOT and PB3 NOT, while PB2 or lamp B. So this is our PB2 or lamp B and push button 3 and lamp A NOT, push button 3 NOT rather, or the earlier. So that is our PLC programming for our latching operation. So if we simulate our PLC program here, so let's review the conditions. If we push push button 1, lamp A should be activated even if push button 1 is not pressed anymore. So yes, you can see here that push button 1 is not sustained, but lamp A is on. And another condition is that if push even if push button 2 is pressed while push button 1 is first pressed, lamp B will not be activated and lamp A will continue to be activated unless if we push button 3, which then resets the whole system. So yes, we reset the system. So now we can press push button 2 and activate lamp B. But if we press push button 1, it will not activate lamp A unless we reset the system. So that is our PLC program. So that is all. So thank you for watching.